This video is about chemical reactions and how to write them and use the right terms. So the first thing we're going to understand is that a chemical reaction is a change that takes place, here's a definition, when one or more substances form one or more new substances. And there's two new words we're learning here, reactant and product. And basically the reactants is everything on the left-hand side, everything that's going into the reaction. The arrow represents a chemical reaction occurring and it's heading in this direction, and it's forming products. So you need to understand that the reactants are on the left-hand side. The arrow represents a chemical reaction occurring and the direction that it occurs. And after the arrow, usually on the right-hand side, are the products. And here's an example. So in this example, we have carbon and oxygen being our reactants. So this is also showing us a symbol for a carbon atom, a symbol for an oxygen molecule. And we always use these little plus signs. This is the arrow showing that a chemical reaction occurs and which way it's heading. And this is the product, carbon dioxide. We use the prefix di because there's two oxygens. Here's a key concept. The mass doesn't change. No atoms are made or destroyed, and that's a principle that no matter can be created or destroyed. The reaction just changes how things are bonding together, and this is a little cartoon showing the reactants, chemical reaction, and then this beautiful new bonding of the product. So there's two ways that we can describe or write chemical equations. The first is a word equation, and this uses the names of the reactants and products. So here's an example. This is a piece of sulfur being burned in oxygen gas, and it produces a white solid sulfur dioxide. Let's have a look at the word equation. It's going to look like this. The word sulfur plus the word oxygen. These are our reactants. Arrow, chemical reaction occurring, and our product, sulfur dioxide. That's a word equation. Now, the alternative is to write a symbol equation. So virtually the same, but rather than words, we're going to use the symbols from the periodic table. We'll come back to the idea of balancing. So this is the same example, except now we're using the symbol S, capital S for sulfur, plus oxygen. And rather than the word oxygen, we're showing that it is an oxygen molecule of two oxygen atoms. An arrow, a chemical reaction has occurred, and the product, sulfur dioxide, written as a symbol. And here we have another sort of cartoon or symbolic representation of the sulfur atom, the oxygen molecule, and the product, sulfur dioxide.